Alright folks, I have just a couple of minutes of battery left, I'm going to tell you. In case this cuts out too quickly, I'll probably post what I have. So what volume in milliliters of a 0.25 molar potassium chromate aqueous solution is required to react completely with, or not completely, excuse me, is required to react with excess silver nitrate aqueous solution to make a product or to produce 1.50 grams of solid silver chromate precipitate. So from all of these words, we have to be able to construct a balanced chemical equation. So you can go back and freeze frame it at this point, but there is my potassium chromate. Remember, we have to know the names of our ions and polyatomic anions. There's my potassium chromate solution, and it's 0.25 molar potassium chromate. I'm adding to it silver nitrate excess. It produces silver chromate solid precipitate, and I know I'll have this left over from the two counter ions have to come together because I have to account for everything here. Balanced. If I put my 2 here, then the whole thing balances. So this is how I write out the given information translated from the words. This is a really good example of a test question on this, but it is where we are in Chapter 4. So we're really building these conversion factor ideas into now incorporating a balanced chemical equation. So what volume of this concentration would react with excess silver nitrate to form this mass? That was my warning. Okay, let's go. So I'm going to start with my mass. So the way I'll convert is a mass of silver chromate to a moles of silver chromate through the balanced equation to a number of moles of potassium chromate to a mass of potassium chromate, and then using concentration from a mass of potassium chromate to moles of potassium chromate to volume of potassium chromate solution. So 1.50 grams of Ag2CrO4 times, I want to convert it to moles, and 1 mole of Ag2CrO4 has a molar mass of 331.7301 grams Ag2CrO4. And then I want to go from moles of this to moles of that, and it's a 1-to-1. So I know that 1 mole of Ag2CrO4 forms from the consumption of 1 mole in this balanced equation of K2CrO4. Now, how much mass is that? Well, 1 mole of K2CrO4 has a, whoops, I'm trying to go too fast. Pardon me, I misled you. I can go right to concentration here, in fact. And I know that, change that, 0.250 moles of K2CrO4 are contained in 1 liter of my K2CrO4 solution, aqueous solution. And I want mils, so I know that in 1 liter of solution I have 1,000 mils. Okay, so my mass of silver chromate goes to moles of silver chromate. Through the equation goes to moles of potassium chromate. And then from moles of that, through the concentration, I get a volume of that potassium chromate in mils. And that is 18.1 mils of K2CrO4 aqueous solution. Oh, whoops, sorry. There we go. Okay, I'm going to shut it down before I run out of battery.